This is Dr.SRIDHARAN from SNS College of Technology. So in this session we are going to discuss about the LED process and applications. So what is the LED? That means light emitting diodes. How does an LED works and how LED emits light and how to working of LED, the construction of LED and advantages and applications of LED we are going to discuss here. A LED is a semiconductor device that emits light when an electric current passes through it. The LED are widely used in display systems for the display technology, indicators, lighting applications, optoelectronic devices due to their high efficiency, long life and low power consumption. The conventional lighting systems use huge power consumptions. For this, LED is one of the very important advantage, low power consumptions. Here is a working principle of the LED. Here also used for the anode and cathode materials and covered with the epoxy material. Principles of operations. The working principle of LED is based on the electroluminescence. When PN junction diode is forward biased, electrons from N-type region recombine with holes in the P-type. Here is a PN junctions. In this slide shows about the PN type of material. The P has a holes and N-type is a electrons. The electrons flow from N to P-type semiconductor. During this recombination process, energy is released in the form of light. Construction of LED. LED consists of PN junction made from direct band gap semiconductor materials such as gallium arsenide, gallium phosphide and gallium nitride. The junction is enclosed in a transparent epoxy resin which protects the device and helps in light emission. So here we use it for PN junction. The materials are gallium arsenide, gallium phosphide, like that, and also used for the epoxy polymeric material. That also very important to close the PN junctions. Metal film connections, light emissions, metal film connections. So this slide so simply explain about the PN junctions and how to construct with the help of the polymers. Working of LEDs, the forward voltage is applied across the LED. The charge carries across the junction and recombine in the active region. The energy released during recombinations appears as visible or invisible light depending on the band gap of the semiconductor material used. So the resolutions and the property based on the usage of band gap, the selection of material, that is also very important part to make it for the quality of LED. Here we shows about the different region, the wavelength, respective the colors. White white is 3 to 5 volt. It records the voltage drop. ultraviolet 3.1 to 4.4 volt. Violet region is wavelength is 400 to 450 nanometer. The required voltage is 2.8 to 4 volt, and blue, green, and orange, red, like that. So the visible LEDs, infrared LEDs, organic OLEDs, and high power LEDs, mini and micro LEDs. So depends on the wave length and voltage. Based on that, we change the colors. Applications of LED. There's a lamp, indicator lamps, digital displays, traffic signal, domestic and industrial lighting, and optical communication systems, and many industrial applications like making instruments, devices also used for the LEDs. The light emitting diodes play a crucial role in modern electronic and lighting technologies. Due to continuous advancement, LEDs are replacing conventional lighting sources and contributing significantly to energy conservation. So this the LEDs are used for the different types of LEDs, and also it has disadvantages, very few disadvantages. The cost is initially high, then many more applications and more advantages also. Thank you.